All right, students, the software I use limits me to 15 minutes. So this is part 2 of the lesson on multiple representations. This is the second page of the worksheet. If you did print it out, you would turn over to the back or look at the second page, depending on how it printed. So on these questions, we're not just looking at input-output tables, we're looking at tables, equations, and graphs all mixed together. So looking at this first example, we are trying to find the relationship between the graph and the equation, which is showing the total number of high school students and the number of high school students that graduate on time. So as we talked about in class before spring break, when you get a graph like this and you're trying to look for equation, I would not go straight from the graph to the equation. I would look at the graph, set up a table, and then try to come up with your equation that might go with it. So as we know, or we should know, the horizontal axis is our x values or our input values, and the vertical axis is the y values or the output values. So to sketch a quick table, I would just do a T-chart, label it with x and y, and then look at the values on the graph. So the first dot we have, it's definitely at 20 for our x value. And we've talked about 2. If you're unsure, you can always draw lines over and to the side to get a better idea on what your values might be. So we know we have a 20 there. The y value is kind of hard to tell what it is. It's definitely greater than 12, but less than 18. It's a little bit more than halfway, but I honestly can't say for sure what it is. So I'm going to look at this next dot. This one is on both lines, so this is a good point to use. Our x value would be 30, and our y value would be 24. So I'm going to fill that in to my graph. If we move on to the next point, we have another one that's not quite on the grid line. So I'm actually going to skip that one for now and then look at the next point that we have, our fourth point of the graph. This one is on both grid lines. It lines up perfectly with 60 and with 48. So that's a really good point to use while I'm trying to figure out my equation. So I'll fill that in on my table, 60 and 48. And again, it looks like from our input to our output, our numbers are getting smaller. If we have 30 students in the class, 24 of them will graduate. If we have 60, 48 of them will graduate. So again, we're either subtracting or we're dividing, and dividing could look like multiplying by a fraction or a decimal. Okay, and because I'm given answer choices in this situation, I don't have to rack my brain to try to figure this out. Looking at my answer choices, they're telling me I can multiply by 12/15 or a fraction, 12/15 or 15/12. Well, I know if I multiply 30 times 12, it is not going to give me 24. 3 times 12 is 36, so 30 times 12 would be 360. Same thing with 15. If I take my input and I multiply it by a whole number, I am not going to get a smaller number as my answer. So I can rule out my first 2 answer choices. They're not going to work with what we're seeing here. So we know it's either going to be C or D. Now there are rules that we've learned that should help us narrow it down between these 2, but if we don't remember those, I'll show you the other way that you can check it. So we can use any values from our table that we made here. Again, I would want to use this one or this one because those were the points that were directly on the grid lines. We can be sure about what the exact values are supposed to be. So I'm going to use 30 as my x and 24 as my y. So if I look at this equation, y equals 12/15 times x. That means when I fill in my values from my table to this equation, that leaves me with 24 in place of y equals 12/15 times 30. So now I've got to figure out what 12/15 times 30 is going to be and if that will give me 24 or not. So remember, when we multiply a fraction by a whole number, we can put the whole number over 1. And when we multiply fractions, we just go straight across. So it's going to be 12 times 30 over 15 times 1. 12 times 3 is 36. So that means 12 times 30 would be 360. And again, I can go over to the side and work that out if I need to, just to make sure. And then 15 times 1 is going to be 15. Well, that's not quite 24, but this is an improper fraction, so I can simplify that and figure out what it would be. Because it's such a large number, I'm just going to go ahead and divide 360 by 15. So I've set up my division problem, 360 divided by 15. 15 can't go into 3 because 15 is larger than 3. So now I'm looking at, will 15 go into 36? Well, 15 times 2 is 30, so that's as close as I'm going to get. 2 times 15 is 30, so I've got to subtract that. It will leave me with 6, and then I bring down my 0 to see what will go in my next spot. So now I'm looking at 15 going into 60. Now, if you can do this in your head, it's fine. If you need to work out some problems and figure it out, you can. I know that 15 times 2 is 30. Not supposed to be a multiplication sign. 15 times 4, again, some of you will know this off the bat, but you might not all. 5 times 4 is 20. 4 times 1 is 4 plus 2 is 6. So 15 times 4 gives me exactly 50. So I have no remainder. 15 goes into 360 exactly 24 times. Now that was a lot of work, but 24 is what we wanted. So 12/15 times 30 gives us this improper fraction, but then when we simplify it, it does equal 24. So this one works out. And if you think back to earlier in the year, here we have an improper fraction. That's actually a number greater than 1. So if I need my values to decrease, that's not going to work. When I multiply x by 15 over 12, it's going to give me a larger number than what I started with. And in this case, we need our answers to decrease. We take x and we get a smaller number for y. So C is the answer choice that has to work out. If this were a test, I'd probably check it again. Do 60 times 12/15, and that should give you 48. But I've already checked it for you, and it does. So we're going to move on to our next problem. Now, students, at any point in this video, if you're feeling comfortable, I would pause it and try to work out the problems on your own, and then you can check it when I show the work. So this next problem might be a good spot for you to pause, try it on your own, and then check it with my work that I'm about to do. It says, which table shows only values that represent the following relationship between Q and R? R equals Q plus 10.1. Q would be our input. We are adding 10.1 to it to get our output, which is R. So if it helps you, if you're used to X and Y, you can think of it as X and Y instead of Q and R if you want to. Q would be like our X, and R would be like our Y value. So we're taking a number, adding to it, and getting a new number. So looking at A, we would take 5, add 10.1 to it to get our R, or our output. 5 plus 10.1, is that going to give me 50.5? I can just estimate really quickly. 10.1 is close to 10. 5 plus 10 gives me 15. So that does not make any sense that I would start with 5, add 10.1, and get 50 as an answer. Let's look at choice B. 5 plus 10 is 15. 7 plus 10 is 17. 9 plus 10 is 19. 11 plus 10 would be 21. So now we can use our actual number. 5 plus 10.1, that would give me 15.1. And I can always check it if I need to. So if I want to double check my work, I can set up an addition problem. 10.1 plus 5 should give me 15.1. Remember, when you add and subtract with decimals, you have to line up the decimal point. So I did that, and I added a 0.0 to my 5 just to make sure. If I go ahead and do the addition, 1 plus 0 is 1. Carry the decimal point straight down. 0 plus 5 is 5. And then 1 plus nothing is 1. So when I do add, I will get 15.1. So B does work out well. If we look at C, it's easy to see right here. Again, I can just estimate. 10.1, round it to 10. 5 plus 10 is 15. That's not going to work out. 10.6, 10.8, I don't know what they're doing there, but it's nothing close to what this equation is telling me to do. You move on to D. D looks good. The very first one, 5 plus 10.1 does give me 15.1, but then it falls apart after that. 7 plus 10.1 would not be 15.3. So you always want to check 2 to 3 times to make sure it's going to work throughout the table. So just like we thought, B is going to be the only answer choice that is good. It's always good to check the rest just to make sure you didn't make a mistake somewhere. Moving on, this is our second to last problem. Mr. Martinez asked his students to write a situation that could describe the relationship between all the values of x and y in the table. So we have x on top, y on bottom, 0 to 6, 1 to 7, 2 to 8, and 3 to 9. We're trying to figure out which written situation would go with these numbers that we already have in our table. So as a reminder, our x values are the input, y values are the output. So if we look at choice A, Rachel had $6 and then started to save $1 each week. So if we look at what this is, maybe X is the dollars, but if she starts with $6 and she's saving $1 more each week, that doesn't make sense. So maybe X is the week. When you're starting out, that would be at 0 weeks. No time has gone by, that's day 1. So at the very beginning of her tracking period, she has $6. 1 week goes by, she's saving $1 each week, so now she would have $7. 2 weeks goes by, she has $8. 3 weeks goes by, she has $9. That sounds like a pretty good description to me, but let's just look at the others and make sure that's the best. B says Beatrice ran 1 mile the first week and 1 mile each week after that. Okay. Another strategy you could use is to make a table of your own. So first week she ran 1 mile. So that's her starting point. A week goes by, she's going to run another mile, so now she's ran 2 miles. Another week goes by, she's ran 3 miles. The way this is going does not match my situation. We're going up by 1 here in our weeks and up by 1 in our miles, but that's too big of a leap for what's going on in our table. We're going from 0 to 6, 1 to 7, 2 to 8. So B doesn't look like it could match up with the numbers that we have. C, James read 0 books in 6 months and then started to read 1 book each week. This is a red flag here. We're going from months to weeks. When we're looking at data that might be in a table or a graph, we are not going to switch the way that we're measuring it. We're not going to go from months to weeks all of a sudden. You have to keep it consistent because remember, we label a graph, we label the axis. We can't label it months and weeks all on one axis of our graph, so that just wouldn't make sense. And then D, Marion has read 6 times the number of toy trains that Tony has. Sorry, I read that wrong. Marion has 6 times the numbers of toy trains that Tony has. So whatever Tony has, Marion's going to have 6 times as much. So Marion's always going to have more. So Marion would have to be the bottom numbers, Tony would be the top. So that's saying if Tony had 0 toy trains, 0 times 6 is going to give me 6. If Tony had 1 toy train, Marion should have 6 times as much. 1 times 6 is not going to give me 7. So that one does not work either. A is our choice, the only one that makes sense. Last problem, the cost of downloading 1 song from a website is 99 cents. Which equation can be used to find T, the cost in dollars of downloading N songs? Again, you can pause right here and try to figure this out on your own if you want to. Okay, so what I've started doing is a strategy that you can do. The important information here is that 1 song is going to cost 99 cents. So with that, I started creating a table. N is the number of songs, and it tells you that. T is the cost. So we know that if we do 1 song, it's going to cost us 99 cents. Everybody can figure that part out. So let's just use that to look at our equations. So if we look at F, the total cost equals 99 cents plus N, the number of songs. So if I have 1 song, that would be my N, The total we know is going to be 99 cents, but if we do the math that they're telling us to do, 99 cents plus